be 2.5 pi e raised to the 0.4x, and I want the table to be at 8.09. That's 69.19 minus, now the 0, is a negative 5.76. Doing the subtracting, 69.19 plus 5.76 is 74.95. Okay, just take your time. There's lots of algebra going on. Just remember what shape you're going to get when it revolves. Is it going to be a cylinder or a washer? And then you can follow the basic formula for whatever shape it is. Let's try one more. So we want the volume of the region bounded by y equals square root of x and y equals 0.5x if that region is revolved around the y-axis. Okay, graph first. You need to know which equation's on top or bottom or left or right. So square root of x and 0.5x. So I can see my square root function rose above the linear function. Okay, bounded here and here. Okay, I need to draw my rectangles perpendicular to my y-axis. So even though I could draw them up and down like this and go around the y, that doesn't work for me. I want to go perpendicular to the axis I'm revolving around. Now I swing around and I'm going to get that washer because there's a gap here. Anytime there's a gap between your rectangle and your axis, you create that washer. Okay, so because I've got my rectangle in a horizontal position, this is a dy. So my a value I want to be a y, and my b value I want to be a y. So I'll find those first by setting them equal. So I've got, so this is to find a and b. I'll go x to the 1/2. That's square root of x equals 0.5x. And I don't think I'll solve that algebraically very easily. So I'm going to go to my handy dandy grapher. I know the bottom one is 0 here. The top one, second, calc, intersect. If you didn't know that, you just have to do the intersect thing. y1, hit enter. y2, hit enter. I'll slide out close to that one. That intersection, I want the y value, not the x, is 2. Okay, so now we're going to set up the washer formula. So the volume is the integral from 0 to 2. Oh, I need my R1. R1 is given by the right function. We're doing right minus left. That's the linear function. So R1 is y equals 0.5x. I don't want to put 0.5x in here because remember I've got y values here. I'm going to have a dy on the end. I need to rearrange this equation to get it in terms of y. So I'm going to divide by 1/2, which is multiplying by 2. So 2y is equal to x, just dividing by the 1/2. This is my R1. I want it in terms of y, not x. So it's going to be pi times R1 squared. So it's 2y squared. R2 is the left function, right minus left. The left function is the square root function. That's the y equals x to the 1/2. I want this to be x equals so that I have it in terms of y. So I'm going to raise both sides to the second power. So that will give me x equals y squared. Y squared is my R2. So y squared, and I've got to square that radius because it's R1 squared minus R2 squared. And then the height is dy. So y boundaries, y values, y expressions for the radius, dy on the end. Okay, each one separately. You don't have to rewrite them. I like to. So this, if I simplify this, I got to square both things. That'll be 4y squared and a pi. So pi times 4y squared dy minus the integral from 0 to 2. This will become y to the 4th, oh, forgot my pi, dy. And then it's each term separately. I guess I didn't need to separate this one because the rule was the same. It's just a simple power rule. So anyway, just add 1 to, there's no inside here, just add just the exponent rule. So add 1 to the exponent, carry along the constants, because those are multipliers. So 4 and pi will carry along. This will become y cubed times by the reciprocal of 1/3. And then here, same thing, the pi will carry. Add 1 to the exponent, y to the 5th times 1/5, and then evaluate from 0 to 2. And it's just calculator work here. So 4/3 pi x cubed minus 1/5 pi x to the 5th, and we're plugging in 2. I get 13.40 minus, at 0 it is 0, so 13.40. Okay, that's your washer. So again, today you're going to have both cylinders and washers. It's just keeping the formula straight. And then we're going to spend a couple more days here too on this stuff. So your assignment, I wrote down somewhere. Page 390. Quickies 4 through 6. And then problems 6 through 10 and 12. Okay.